In our lesson today, we're going to talk about first chemical compound word problems, and then we're going to talk about parallelograms and their properties and how those can help us find missing things when we're given a picture of a parallelogram. So first off, how many of you are taking chemistry this year or have already taken chemistry? So a few hands going up there. So you guys are my experts. Make sure I get this straight. Keep me honest. You're going to be several steps ahead of a lot of your classmates because you already know all the abbreviations on the periodic table and some of that kind of stuff. Other people here have not done anything with that yet. So we're going to try to make it where everybody can understand it. So the basic idea on these is we have different elements and we can put atoms of those together to make molecules of other compounds. Probably the most famous one or the most well-known, H2O is what? Water. And what H2O means is that one molecule of water has two atoms of hydrogen and one of oxygen. Did I get that right, those of you in chemistry? Okay, just making sure you're keeping me honest. So each of those atoms has a unique weight. In chemistry, you use the periodic table showing all of those. And our math class, each problem is going to tell you in parentheses at the end what those weights are, because some of you haven't had chemistry yet. So we're going to set these up with a ratio box to solve them. So this one, like I said, water. So what we are going to do, if it is H2O, we are going to start off with a table, and we are going to write down H2, including the number, and O. Those are the two kinds of elements that we are working with in this problem. The H was for hydrogen, the O was for oxygen, but you don't need to know that on all of these and write all of that down. Some of the problems will tell you, others won't. You need the H2O. Then the problem tells you in parentheses, so if you could get off of the periodic table, that each atom of O has a weight of 16, or each atom of oxygen, if you know that O is oxygen, and each atom of H, hydrogen, if we happen to know that's what H stands for, has a weight of 1. So since I have two atoms of hydrogen, and each, well, first I'm going to write those down in here so I know what I'm doing. I'm going to make sure, oh, they told them to me here in the reverse order. Usually they do the same order, but make sure we got them in the same order there. So each one weighs that. If I have two of the hydrogen and each one is 1, I have a total in that molecule of 2 for the weight of the hydrogen part. I only have 1 of oxygen, so in one molecule the oxygen has a weight of 16, which means the molecule has a total weight of 18. Then it becomes a ratio box. We know that we have a total of water of 3,600. And then they ask us to find the oxygen, so we put a variable in the correct row. And I try to use something that hasn't already been used in the problem, so I'm going to use X. So I am looking at, just like in any ratio box, 16 over 18 is X over 3,600, and I don't need the top row anymore. It was only needed long enough to get the 18. Is everybody good with that setup? Okay, several ways you can solve this, and I'm going to set it up different ways, and you pick whichever way you like best to solve it. Somebody tell me one way I can solve that proportion. Amelia? Okay, we've been doing a lot with cross multiplication. You can certainly do 18x is 16 times 3,600 and then divide by 18. What's another way we could do it before you start solving that? Riley, what else could you do? And so you could say 8 over 9, and then you do the cross product, or you do something else. Okay, so that would also work. What else could you do? Another idea of this? Well, I don't really care if 16 goes to 2,600 because they're not going to end up in the numerator and denominator on the same side. You on one side and an equal sign. Okay, when you were solving algebra problems and you had x divided by 7 equals something, what did you do to both sides? How did you undo divided by 7? Multiplied by 7. So what I've got on the left is simply x divided by 3,600. So I could multiply both sides by 3,600. Oh, that looks exactly the same as what I've got on that one. One other way we could solve it. If you have a fraction, besides dividing numerator and denominator by the same thing to reduce it, what else can we do to the numerator and denominator? Like when we're getting common denominators, what do you do to both numerator and denominator? You don't divide, what do? You multiply numerator and denominator by the same thing. So if it's easy to look at it and say, oh, well, the x is in the numerator, so I don't know about it. What about the denominator? Can I easily figure out and see what I multiply 18 by to get 3,600? Well, 18 times 2 is 36. So 18 times 200 would be 3,600. Multiply the numerator by the same thing, and that's got to be x. So, everybody done it one of those ways already? What do you get for x? Shout it out, everybody. So no matter which way you pick, x is 3,200 grams of oxygen. Questions from anybody there?
If you don't know the names of the chemicals,
You can just do the O, or if it is a really long name and you do know it, you can do the symbol for it. All right. Speaking of really long names, let's do one with dichloromethane. I think is more or less how you pronounce that. Otherwise known as Freon 12. Well, we really don't even care about that except that that's the total thing that we're looking at. What we care about is it's made up of CCl2F2. Now, those of you in chemistry likely know what C, Cl, and F all stand for. Those of you not in chemistry likely don't know those, and that's totally fine for math class. We just are going to then write down that we have C, Cl2, and F2. And then at the end of it, it's going to tell us 1 atom of C weighs 12, 1 atom of Cl weighs 35, 1 atom of F weighs 19. Since I have 1 of the carbon, or 1 of the C, 1 times 12 is 12. I have 2 of the Cl, so 2 times 35 is 70. I have 2 of the 19s, 2 times 19 is 38. And that's enough that I can add them up and get my total of, I believe, 120. And that's my total, which is CCl2F2, or Freon 12. They also told us that in their whatever, for the total thing now. Then we see what it is we need to find. We have 1,200 of the Freon 12, that's the total. So we have 1,200 on the total. And we want to find carbon, or the C, and usually the book will do something like that to make sure you know which letter it's talking about there. So I'm going to pick something and put in the C row. I no longer need the 70 and the 38. That was just enough to get me the 120. So the part I'm still looking at is 12 over 120 equals X over 1,200. Think about the different methods for solving that I just reviewed. What do you think is going to be the fastest one to use? Okay.
Multiplying by the same thing.
Specifically by what? Multiply numerator denominator by 10? Would you agree if we look just at the denominator that we know? If we multiplied by 10, we'd have the denominator we need. So to get the numerator, we need to multiply the 12 by 10, and what do we have? 120 grams of carbon. Questions from anybody on those kinds of problems? And let's move on to parallelograms. And we're going to have 5 things that we know about parallelograms and can use. The first one is just the definition. If you have a parallelogram, that means both sets of opposite sides are parallel. These are parallel, left and right, and top and bottom are going to be parallel. That is our definition on the parallelogram. It has properties. The first property we're going to write down is that the opposite sides are not only parallel, but the opposite sides are also congruent. The top is just as long as the bottom, the left is just as long as the right. When we are doing abbreviations in problems, we probably ought to start writing out a little bit more. From what I'm seeing on some of your work, some of you are just trying to memorize letters, AIA, IT, IQ, IA, and you're not remembering what they stand for. You're just trying to remember the letters, and you're getting them all jumbled up. So maybe we ought to start, even on the old ones, trying to write out a few letters for each of those things instead of just single letters. So maybe on this one, parallel sides are also the opposite sides. We might abbreviate opposite sides congruent. That really is not that much writing. That is not going to give you a severe case of writer's cramp to write that much out. And it makes it clearer that you know what you're talking about. So far we have opposite sides are parallel, opposite sides are congruent, and our next one says that opposite angles are also congruent. So notice in that parallelogram, unless it's a rectangle where everything's 90 degrees, one set of opposite angles is going to be acute, and one set of opposite angles will be obtuse. And this is just saying, if it's a parallelogram, those obtuse ones are congruent, and those acute ones are congruent. These properties do not work if it's just a regular quadrilateral. It's got to be a parallelogram for that to work. And we might abbreviate this one as opposite angles congruent. Opposite sides parallel, opposite sides congruent, opposite angles congruent. Somebody give me a guess, what would happen if I took adjacent angles, if I took the angles that are next to each other? What do you think would happen if I took A and B? Or A and B, one acute and one obtuse. Ada, what do you think would happen?
It would add to 180.
You are exactly right. So adjacent angles are going to be supplementary. They are going to add up to 180 degrees. Taking one of the acutes with one of the obtuses. And again, this is only if it's a parallelogram, not if it's just a regular quadrilateral of some sort. And we might label that one as adjacent angles are supplementary. For our last property, we're going to do something a little bit different here. We are going to draw the diagonals. So we're going to take those opposite angles and connect them with diagonals. The diagonals are usually not the same length. If you look at that, doesn't it look like AC has to go farther than BD? So the diagonals themselves are not the same length. But they cross in the middle, and they cross in a special way. If I take the two pieces of AC to the left and to the right of E, those two pieces are congruent. If I take the two pieces to the left and the right of E along BD, those two pieces are also congruent. So the diagonals bisect each other, and we probably should label that something like diagonals bisect, and I do want you to say each other because there's another property we will get to later where they also bisect angles, at least in certain cases. So, everybody good with what that one means? So 5 things on parallelograms. Definition: opposite sides are parallel. Also, opposite sides are congruent. Opposite angles are congruent. Adjacent angles are supplementary. And diagonals bisect each other. And those are the things we want to use on the 2 examples that we're about to do. So are we ready for the first one? So I have this very messy looking picture. I've got the parallelogram and I've got the diagonals drawn in it. And I have a whole bunch of things that I need to find. I need to find 2 angles, and I also need to find x and y. Why don't we do x and y first? If we look at this picture, what they are saying is that this piece is x plus 2. They are saying that this piece is 2y minus 4. They are saying this piece is 6, and this piece is 8. So, what was the property about diagonals? What do the diagonals do? Grayson, what did you write down that the diagonals do? They bisect each other. So, tell me 2 things that means have to be equal. Who wants to try to tell me 2? All right.
2y minus 4 equals 8.
So, is everybody comfortable with 2y minus 4 and 8 have to be equal to each other? Those are 2 pieces of the same diagonal. So that means 2y is 12. So everybody shout out what that means y is.
6.
And my reason needs to be, up there when I first wrote the first equation that I solved, diagonals bisect each other. Okay, so I've gotten y. Is there anything else that I know from this picture that will let me get what x is, perhaps? Jack, do you see anything in the picture that I can write down for x? Everybody good with x plus 2 equals 6? Same reason as before, that diagonals bisect each other. So when you have 2 that use the same reason, if you've written them in places in your box where you can just draw an arrow to both of those equations, it's okay to do that and not have to rewrite the whole thing. So everybody shout out for me, what is x? So we've done the x and the y part. Now, because my picture's a little bit messy, you wouldn't probably do this on your paper, but I'm going to do it to make it a little bit easier to explain as we talk about it. I'm going to redraw the picture without the diagonals in there. They tell me in there that ABC is 125, so that would be this angle up here. And I'm going to look at which ones do they want me to find, because they only want me to find 2 of the others. They want me to find DAB, so if I start at D, go to A and to B, oh, okay, I need to find that one. And then they also want me to do BCD, so if I start at B, go to C, and go to D. So I only need to get those 2. I don't need to learn the lower right. So I know 125. What am I going to get to? What am I going to use to get either the one that I just outlined in red or in green? Yo-yo? And so which adjacent angle are you thinking about? So you're thinking about, let's use A and B. So this one right here. And we can say that adjacent angles are supplementary. So we can take the 125 plus the measure of the angle that's at A, and we have to get 180. Now I'm really going to write that as DAB, because you'd really just be looking at the picture like this that's in your book when you write this down. And if you just say A, I don't know if you mean that or the whole thing, So we're going to write it down with all three letters. So subtract 125 from both sides. And can you tell me how big the measure of angle DAB would be? Shout it out, everybody. 55. It does not have a degree symbol in the picture, so we need to say with degrees. So now we know this is 55 degrees. Bob, how can we find C?
You can do A equals C because of adjacent angles are supplementary.
Adjacent would be B and C or C and D. A and C aren't adjacent.
Opposite.
They're opposite. So we can simply then say that the measure of angle, and I'll get all three letters in there in a minute, of the angle at C has to also be 55 degrees because opposite angles are congruent. And the full name of C was BCD. And we have solved that problem. Questions from anybody on that? Okay, one last example for the day. Another parallelogram, just angles. We don't have any diagonals thrown in there. And for this one, I want to illustrate, let's be smart. Let's think this through before we write everything down. We know adjacent angles are congruent, and we know adjacent angles are supplementary, opposite angles are congruent. So I could say that these opposite angles equal each other. I could write down x plus 50 equals 10y plus 70, and that's correct. One equation. How many letters in that equation I just said? With both x and y. One equation with two letters isn't enough that I can solve it. Okay, I could do adjacent angles are supplementary. So I could do A and B add up to 180. So I could write down x plus 50 plus 8y plus 20 equals 180. How many variables in that equation? Two. X and y are in that also. So I could take both of those, two equations, they both have x and y, do a system, substitution or elimination, and solve it. Now let's keep thinking before we start writing. We've got one approach that'll work, but let's see if there's anything else instead. I've also got this pair of adjacent angles, so I could write those down and say that they're supplementary. I could write down 8y plus 20 plus 10y plus 70 equals 180. How many letters in that one? One. So, we need everybody to vote. How many want us to write down two equations with x and y and solve a system? That's our first step. How many want us to do that last equation and just solve for y as our first step? The majority rules, I agree with it. That's what I mean about being smart. Trying to think through different possibilities. So we're going to say 8y plus 20 plus 10y plus 70 is 180. And our reason for that is adjacent angles are supplementary. So we have 18y plus 90 is 180. Subtract the 90 on both sides. 18y is 90, and y is 5. All right. So y is 5. So now we know that. We still need to find x. The only one with x in it is this one up here. I do now know that both of these y's are just 5s. So tell me what I do with angle B and something that I know to be able to figure out what x has to be. Abby. Okay, so everybody good with that? Abby is saying that A and B are adjacent. So we can say that, again, the adjacent angles are supplementary. So we can say that the x plus 50 plus the 8 times, we now know that y is 5, plus 20 has to add up to 180. So we have 50 plus 40 is 90. We have x plus 110 is 180. So what is x? So that x is 70, and we have found both of them. You could have, and I'm not going to do it a second way, but it would have been just as good to say x plus 50 equals 10 times 5 plus 70. Opposite angles are congruent. Doesn't really make a lot of difference on that choice. Questions from anybody on what we have done today?